Hello, ladies and gentlemen. It's test day coming up. If we don't get coroned out of here, who knows what's going to happen. Let's go ahead and do some simplify problems because we're going to go ahead and keep moving. First thing, when you see these problems, there's probably multiple ways you could approach the problem. When I see 1 minus cosine squared, I'm like, that's a thing. So let me remind you your trig identities. Sine squared x plus cosine squared x equals 1. That is our Pythagorean identity. Now, while I'm at it, I'm going to find the other two because I might need them in other problems. When you see sine squared plus cosine squared x, remember, you could move this cosine squared over and it would be 1 minus cosine squared x, and that would get you sine squared x. So that's what I'm going to do for this problem. But let's get the other two while we're here. If you divide everything in this problem by the sine squared x, so if I take this guy and I divide all the terms by sine squared x, which I'm not going to write it all out, sine squared x divided by sine squared x is 1. Cosine squared x divided by sine squared x. Cosine, that's cotangent squared x. And 1 divided by sine squared, 1 over sine, is cosecant squared x. So there's another Pythagorean identity. I can do the same thing, but divide all these by cosine. So sine divided by cosine is tangent. That's going to be tangent squared x. Plus cosine squared divided by cosine squared is 1. And 1 divided by cosine squared is secant squared x. So there's a third trig identity. I'm not going to give you these three on the test. You need to be able to remember them or derive them if you need them. So let's go with that now. If you see 1 minus cosine squared, you're like, hey, that's a thing. That's sine squared. So I'm going to say sine squared x. And I'll write that over 1. Cosecant x, I'm just going to write that as 1 over the sine of x. Now, if you look, you're multiplying. So this is division. The fraction bar is division. I can undo that with the division. So one of the signs will cancel out, and you just get the sine of x. Cool, that's not too bad. Let's try another one. Can we do this with trig IDs? Let's see. 1 minus cosine squared. Sure, 1 minus cosine squared, that's a thing. That would be sine squared over secant squared x minus 1. Secant squared x minus 1. Secant squared x. That's tangent squared. We're moving along. Okay? So I have sine squared x over tangent squared. Now let's rewrite that in terms of sine and cosine. So in the numerator, I'm going to say I have sine squared x and it's over 1. In the denominator, I'm going to say I have tangent squared. That's not what bothers me. Tangent squared in the bottom, which is sine, no, be a pen, there you go, sine squared x over cosine squared x. So now that I have a fraction over a fraction, I can do a little copy, change, flip action. So I'm going to multiply by the reciprocal. This is my numerator. I'm going to change this into multiplication, and I'm going to flip this, so it will be cosine squared x over sine squared x. And when you know it, the sine squareds cancel out, and you just get cosine squared x. That's not the only way to do that problem. I could have also gotten a common denominator in the denominator. I'll do that really quickly just to kind of show you. I'm not going to show all my steps, but this is 1 minus cosine squared x over cosine, no, secant is 1 over cosine squared x minus, instead of 1, I would make that cosine squared over cosine squared, which then in the numerator I have 1 minus cosine squared x over 1 minus cosine squared x over cosine squared x. If you copy, change, flip, this is in the numerator times cosine squared x is now in, oh geez, cosine squared x over, again, this is now in the denominator. If you copy, change, flip, numerator, change, flip. These are going to cancel out, and you just end up with cosine squared x. Same thing, different way to get there, lots of approaches. Let's try a couple more. Cosine squared plus cosine squared. Cosine squared. Generally, when you see multiple different trig functions, it's a good idea to factor. But let's see what happens if we just make everything in terms of sine and cosine, because it might work out fine that way too. Sine squared x over cosine squared x. So all I'm doing is taking tangent and rewriting it as sine over cosine. When you do that, you have cosine squared over cosine squared. Those cancel out. And you're left with cosine squared x plus sine squared x. Hey, that's a thing. That's 1. We got it. Okay. You could have probably factored out a cosine and gotten there the same way, but that's pretty efficient. Whoa, my lights just went out. Crazy. Okay, let's do another one. Tangent theta. So that would be sine of theta over cosine theta. Generally, a good approach is to make everything in terms of sine and cosine. So cosine over sine. and then I have cosecant, which is 1 over the sine of theta. Okay. Now, to get a common denominator, I need to multiply these denominators together. So I'm going to give this guy a sine of theta in the top and the bottom, and this guy a cosine of theta in the top and the bottom. This is kind of just back. We've done this a bunch of different ways. Rational functions. Sine squared plus cosine squared. Sine squared, that's a thing. Over sine of theta times cosine of theta. That's in the top. In the bottom, I still have 1 over sine theta. Cool. All right. But now I have a fraction over a fraction, so I can copy, change, flip. So I'm going to take this whole thing. Actually, no, I'm not, because look, this is a thing. Sine squared theta plus cosine squared theta, that's 1 over. And then this would be sine of theta times cosine of theta. Copy, change. Now we'll flip this one, so sine's in the top. Okay. Copy, change, flip. Wait, it's over 1. I'm sorry. I don't know why I wrote cosine. Sine of theta over 1. So what happens? See ya. You have 1 over cosine theta. 1 over cosine theta. That's secant theta. So again, you could probably do that differently, but that was pretty efficient. So making everything in terms of sine and cosine, usually a pretty good strategy. Okay, evaluate exactly. Let's see what we can do here. Cosine of 165. Remember, think about your unit circle. We have reference angles of 30 degrees. We have reference angles of 60 degrees. We have 45 degrees. We have 90 degrees. I could also do multiples of those. So I could do, let's see, 120 degrees. I could do 135 degrees. I could do 180 if I wanted. There's lots of ways I can get to 165. But I got to find 2 angles that add to 165. So what angles add to 165? I could do 120 and 45, or I could do 60 and 130, or I'm sorry, 30 and 135. Let's do 120 and 45. So I'm going to do those two. So I'm going to rewrite this as the cosine of 120 plus 45 degrees. Now, when I get to that step, I'm not going to distribute cosine because I understand the rules, and that is not a rule. When you see cosine of a sum, you need to come up here and be like, that's this. It is not distributing. Oh my, I'm freaking out. Okay, let's use the rule. So cosine of S, that's 120, times cosine of T, that's 45, minus sine of S, sine of T, sine of 120, sine of 45. I'm expanding it using the rule. Now I need 120 and I need 45. So I'm going to think 120 is over here in the second quadrant with a 60-degree reference angle. So this would be negative 1/2 and positive radical 3 over 2. So the cosine of 120, that's this, negative 1/2. Cosine of 45, radical 2. Those are being multiplied. Minus sine of 120. Sine of 120 is radical 3 over 2. And the sine of 45 is radical 2 over 2. So we end up with 1 times radical 2, which is, and it's negative, so negative radical 2, minus radical 3 times radical 2 is radical 6, and these have a common denominator. It is 2 times 2, which is 4. So negative radical 2 minus radical 6 all over 4. That is the cosine of 165. You can type in your calculator and get the decimals, but they're not going to help you other than checking your answer. You don't have your calculator on the test, so who cares? Sine of negative 7 pi over 12. What do we got here? Let's see. How can we get negative 7 pi over 12? Now, these are radians, and it's tangent. When you're dealing with tangent, you don't want to mess with 30 degrees. Just don't do it. It makes it harder. There's no reason to. So let's think about what angles I can use. Pi over 3, pi over 4, and maybe pi over 2. And then they're multiples. I need to get pi over 12s, so let's think about those as, if I multiply the top and the bottom by 4, 4 pi over 12. 3 pi over 12 times 6, 6 pi over 12. How am I going to get negative 7? Well, I can make both of these negative and add them together. So I'm going to say the tangent of negative 4 pi over 12, which is pi over 3. And then I'm going to say plus negative pi over 4. Now, this can be done a couple different ways. If I do it with the addition, this is going to be a negative. If I do it with the subtraction property, then that will be a positive I was dealing with. So I'm going to make them both negative because I think that makes the most sense. But when you add these together, you get 7 pi over 12. I want them to both be negative. Now I'm going to do it with the addition property. So I'm using this property right here. So I'm going to say the tangent of negative pi over 3 plus the tangent of negative pi over 4 all over 1 minus the tangent of negative pi over 3 times the tangent of negative pi over 4. Now you got to be careful, since I'm evaluating these angles and they're negative, they're going to be in the fourth quadrant, and tangent is negative in the fourth quadrant. So you should remember that if you're talking about a 60-degree reference angle, tangent of a 60-degree reference angle is radical 3. So in the fourth quadrant, that's going to be negative radical 3 plus the tangent of negative pi over 4. Negative pi over 4 is right there, and sine and cosine are the same, so that would be negative 1 over 1 minus. This is still negative radical 3, and this is still negative 1. So you got to be really careful with your signs. This is negative radical 3. I'm going to write it as minus 1 over. So what happens here? Those cancel out, but you still have 1 left. So it's going to be 1 minus radical 3 in the denominator. That's kind of tricky. Now I have to rationalize the denominator. So to rationalize the denominator, when you have a sum, usually what you're going to do is deal with the conjugate. So we're going to multiply by the conjugate, which is instead of 1 minus radical 3, 1 plus radical 3. 1 plus radical 3. Now I'm going to FOIL. Negative radical 3 times 1 is negative radical 3. Negative radical 3 times positive radical 3 is negative 3. Negative 1 times 1 is negative 1. Negative 1 times radical 3 is negative radical 3. Over, in the denominator, 1 times 1 is 1. 1 times radical 3. Negative radical 3 times 1. Oops, radical 3. And negative times a positive is going to be negative 3. The whole reason we use the conjugate is right here. Those cancel out. No more radicals in the denominator. Now I have a radical 3 and another radical 3, so that's 2 radical 3s. They're negative. And negative 3 and negative 1 make negative 4. All over 1 minus 3 is negative 2. Now I can take that negative 2 and I can distribute it. I mean, I am distributing, essentially I'm multiplying times 1/2. I'm going to take everything divided by negative 2. So negative 2 divided by negative 2 is positive 1 radical 3. So 1 radical 3, I'll just write radical 3. And negative 4 divided by negative 2 is positive 2. So the final answer is radical 3 plus radical 2. Now it takes a while. I think, though, the hardest part is getting these two angles. So think of what angles you've got, put them over 12, and then figure out how you can add or subtract to what you need. Especially when it's negative, that can be tough. A couple more things to do here. We got some verify problems. So these are essentially what we're doing on the front, only I'm telling you the answer. So you want to pick either the left or the right side, and you're going to manipulate it, use all your rules until you get to the other side. Pick the side that looks harder. That seems sometimes counterintuitive, but it gives you more things to try. So definitely I'm going to work with the left side. And I think what I'm going to do first is I'll probably just distribute. So I'm going to multiply this whole thing. This is a product. So this would be the sine of theta times the cosine of theta, which I'm going to multiply by tangent. So tangent of theta plus the sine of theta, cosine theta times cotangent. Okay, now let's make everything in terms of sine and cosine, see what happens. Sine of theta, cosine of theta. Tangent is sine of theta over cosine theta plus sine of theta, cosine theta, cotangent, which is cosine over sine of theta. Okay, so can I do anything right now? Yeah, those go away. Yeah, those go away. This is a quantity. Okay, that's one term. So I'm allowed to do that because this is all being multiplied and I'm undoing division. So just be aware. These are two different terms. I cancel out the cosine in the first one and the sine in the second one. Now I have, in this first term, sine squared theta plus cosine squared theta. Hey, wait a minute. That's a thing. That's 1. Good. It's supposed to be. I did it. Okay? It's a proof. Let's do another one. Sine of x minus pi over 2. What you're not going to do is distribute sine again because I'm going to freak out. Let's use property. Sine of x minus pi over 2. So x minus pi over 2 is this one. It's a difference formula. The sine of x times the cosine of pi over 2. Be careful. Minus the cosine of x times the sine of pi over 2. Okay, these signs sometimes can mess with you. Like that one stays negative, but with cosine, the sign flips. Just be careful. Copy the formula carefully. Pi over 2 is right here on my unit circle, so that's at 0, 1. So when I say what's the cosine of pi over 2, that's the x. So 0 times the sine of x minus the sine of pi over 2 is 1, so 1 times cosine of x. 0 times everything is 0, so that goes away, and negative 1 times cosine is just negative cosine x. What am I trying to prove? Oh, that is negative cosine x. Sweet, I did it. Okay, one more section. Last thing is, it's essentially the same ideas, but we're going backwards now. So this is a property, but we got to figure out which one it was, which one expanded. So look, which one's got a sine times a cosine plus a cosine times a sine. Sine, cosine plus cosine, sine. What I'm saying is, that's really this property. Okay, that's what I got here. But let's think about what they plugged in. Why would that get bigger? Oh, that's too big. Okay, that's this property. So what I'm doing is I'm saying, okay, they made S 18 and T 27. I can do that, but I'm going to go back to here and say S is 18 and T is 27. 18 plus 27 is 45. Hey, wouldn't you know it? That's on the unit circle. The sine of 45 is radical 2 over 2. We're done. You just have to find the property and then work backwards. Sorry, I got people knocking on my door. Let's do one more and we'll call it. What property is that? Cosine, cosine plus sine, sine. Cosine, cosine plus, that's this guy right here. So that is the cosine difference formula. There you go. See it? Cosine, cosine, sine, sine. That means that we're going to take these two angles and we're going to subtract them. So this is the cosine of 3 pi over 7 minus 2 pi over 21. Okay. We better get a common denominator. So you got to triple this guy. That's 9 pi over 21 minus 2 pi over 21, which is 9 minus 2 is 7 pi over 21. We're going to get there. 7 pi over 21, cosine of 7 over 21 is 1/3. So this is the cosine of pi over 3. Pi over 3 is in the first quadrant, 60-degree reference angle. I want cosine. That's the short side. This is 1/2. So this whole mess is really just 1/2. Figure out which property it is. You're kind of going backwards. So stay healthy out there. Be sure to like and subscribe. Don't cough on each other. Good luck on your test.